Right, so this section is going to be about endochondral ossification. So this is pretty tricky for a lot of people, so make sure that you've really got this down, and if you have a question about anything that you let me know, okay? This is not just a simple memorization. This is processes that are getting more difficult. So if you don't know the prefix endo, it means inside. Chondro is going to deal with cartilage, and then ossification is going to mean the hardening or turning to bone, okay? So I'm going to try to kind of read through this and just hit my pen along the way as I do, and then supplement a little bit, and I may end up repeating myself a couple of times about a few things to really drive a few major points home, okay? So when we're talking about fetal development in embryos as early as 8 weeks, okay, in the developmental process, the skeleton's going to start to form in the form of what are known as hyaline cartilage models, which you can see down here. They're typically in the shape of a long bone. They have a connective tissue membrane around them that's going to become really highly vascularized, which it mentions here in this sentence. So a nutrient artery is going to start to grow into that connective tissue covering. That covering in utero is going to eventually develop into the periosteum, which we've said is the mature connective tissue layer over all bones, and it's highly vascularized, right? So now we've got this increased nutrient supply and blood supply, okay? It says with that increased nutrient and blood supply, precursor, bone forming cells that are within that periosteum, they're going to develop into mature bone forming cells known as osteoblasts. Okay, so essentially those osteocytes that we've been talking about, they're going to develop into osteoblasts. Okay, these bone forming cells, they are going to start to develop bone matrix along the outside of that hyaline cartilage rod and make what's known as a bone collar, which you can see labeled in the top part of this diagram. So it's just a supportive little collar along the bone that's developing. All right, and so that bone collar has formed, and so on this slide it says cartilage producing cells that we know are chondrocytes. They're inside the rods of cartilage. They're going to start to grow really large, and it's kind of said to be a super growth, right? That's going to signal hormone secretions, and that cartilage matrix is going to start to calcify and actually turn to bone, okay, or harden. It says the newly formed calcified matrix is now going to be impermeable to nutrients. So those huge chondrocytes from this super growth, they're going to die because nutrients can't get to them, okay? And so once those chondrocytes die, the matrix that's around them is going to start to break down or deteriorate, and that's going to form cavities within the central shaft or the diaphysis of the what's going to eventually become a bone when we're looking at just the hyaline cartilage long bone model that we can see here. Okay, and so we're seeing those enlarging chondrocytes in that diagram. Hopefully you can read what that says there. Let me pause it for just a second. All right, so now just to kind of tag on at the very end there, again, that the matrix around those huge chondrocytes is starting to break down, and it's going to open up the internal region of the diaphysis. Okay, so on this next slide, it says then a nutrient artery is going to then grow into those cavities, and that's going to deliver bone forming cells. Those osteoblasts, again, are going to form bone, but it's also going to deliver osteoclasts, and osteoclasts are going to break down bone. Those are going to come from the outer connective tissue membrane that again is the periosteum. Right, so the osteoblasts that are going to form bone, they're going to start to secrete bone matrix around the remaining fragments of cartilage. That's going to create early spongy bone that we can see here in this section of this diagram. Okay, and that again, spongy bones characterized by all the little open spaces in the trabeculae. This says early spongy bone creation by osteoblasts laying down bone around the shaft in the middle. Okay, and that middle region is called the primary ossification center. Okay, and again, there's cartilage there in that region. All right, and so now just over time through this process, the osteoclasts that are going to break down bone, they're going to do that, and as they break that down, that's going to open up, or breaking down, sorry, that newly formed spongy bone, that's going to break up that central space that's going to turn into the medullary cavity. And that medullary cavity is located within the shaft or the diaphysis of a long bone, if we go back to the anatomy of a long bone worksheet. Okay, So then it says at birth, the cartilage located at the ends of the epiphyses, that's going to continue to grow. So that cartilage is not going to go through this process. Okay, so it says the developing bone is going to increase in length, okay, at the epiphyseal regions. Bone formation or ossification within the bone ends or epiphyses is similar to that in the shaft or the diaphysis, except the spongy bone characterized by open spaces at the bone ends is not broken down. Sorry, I was kind of starting to read to see where I was going with that. Lost my train of thought for a second. But essentially what's happening here, as it says, your ossification or your bone formation within the epiphyses, the ends of the bones, it's going to be similar to what's happening in the diaphysis, but the spongy bone is not ever going to get broken down, okay? And so then the last sentence here says when bone formation, or what we said is known as endochondral ossification, is complete, the hyaline cartilage is going to stay over the surface of the ends of the bone. That's what we labeled as articular cartilage, and that's going to allow for cushioning and shock absorption at the articulation point between two bones, okay? This whole process, this little asterisk here, it says this is also what's responsible for the healing of a fracture in people that are of mature height, okay? Our bones will go through this process as well. Let me pause it just for a second. Okay, so I'm going to jump to this diagram for just a minute. All right, so again, when we're developing, we have little rods of hyaline cartilage that are models, okay? And as it says up here, the chondrocytes at the center of those hyaline cartilage models, they are going to start to grow and be huge. And once they grow and they're huge, then the matrix around them basically cuts off their nutrient supply. And so then those cartilage cells are going to die, okay? Then in this next section of this diagram, it says newly derived osteoblasts that are going to cover the shaft of the cartilage and a thin layer of bone. That bone collar was mentioned earlier in the notes than this was at the very beginning of this section, but it's fine. Just know that that bone collar has formed. Notice now we've got a nutrient artery that's going to deliver both osteoblasts and osteoclasts. Okay, again, blasts are building. Just think about the bees. Okay, clasts, osteoclasts are breaking down bone. And so then here it says blood vessels are going to penetrate the cartilage. Right, new osteoblasts are going to form that primary ossification center that we see here. So this is where we're going to see new bones starting to be laid down. It's going to be spongy bone. Right, then the osteoclasts are going to come in and they are going to start to break down that spongy bone. That's going to open up this space that we see here within the shaft of the bone, and that's going to turn into the medullary cavity, right, that eventually will have yellow marrow within it. Okay, and so that being said, up here it says the bone of the shaft thickens, the cartilage near the epiphyses, or each epiphysis, is replaced by shafts of bone. Again, at the ends, this whole process is going to happen essentially in the same way, but that's never going to turn to compact bone. It's just going to stay spongy bone. Okay, and so let me pause again for a second. Okay, so that being said, sorry, I forgot to say one other thing, that the blood vessels, as it mentions up here, that we're going to have blood vessels delivering cells and oxygen and nutrients in the same way that we've talked about in the diaphysis region. So this is going to form ossification centers at either end of the bone as well. So now I'm going back to this slide. These things in red, okay, so basically at birth, most of our hyaline cartilage models are now bone, right, with the exception of the articular cartilage and the epiphyseal plate, which is known as the growth plate. Right, the second red bullet says bone is also laid down on the outer surface while it's being broken down around the medullary cavity. So that's how the bone's going to get wider. So let me go back to the other diagram for just a second. So let's use this fourth image for that. So essentially, as the medullary cavity is opening up, bone's also getting laid down on the outer surface of the body, so the bone will get wider. So you just have to imagine that in this diagram, this central shaft region is opening up more, and that the bone is getting wider on either side, essentially in both directions as well, as new bone is being laid down. Okay, and then just kind of for some perspective as far as bone growth, this last red bullet, so it says your bone mass doubles between birth and age 2. It also basically doubles again by age 10 and doubles again during puberty. right? So if you're still growing, then you've still got some additional weight of bone that's going to be added to your body. Girls, you're probably done with that, to be quite frank. Boys, you probably have some more growing room to do. It says it increases until about 30 years of age, and then after that we start to lose about 5 to 10% of our bone mass per decade, right? So if we say, for me, again, I've started to lose about 5 to 10% of that at this point, being 44, okay, probably closer to the 10%. And so we're going to talk about what that means as far as, losing bone mass over time. We'll get there eventually. All right, and then back to the concept of endochondral ossification, but that hyaline cartilage is going to stay at the ends of our long bones. So that cartilage, again, it's going to serve to reduce friction at our joints, okay? The hyaline cartilage is also going to remain between the bones or the bone ends at the shaft in a growth region. Sorry, I'm getting all tongue-tied. Let me just totally start over. Okay, so it's going to reduce friction between just two different bones, cushioning and shock absorption. And then it's also going to stay, if you look right here at this line, this epiphyseal plate, that's the region that we know is the growth plate. So cartilage is going to stay there so that we can continue to grow. And then eventually that's going to harden up, okay, and become a line that over here basically really can't even see it on this image, okay, but you can tell that circle right there, that's the patella, this is the femur, and then this is the tibia, and that's the fibula. All right, and so if somebody breaks a bone at the growth plate, then typically their bone will be shorter than it would if they did not break a bone at the growth plate, because it does impact overall bone growth if you have a break when you're still developing. Let me know if you have any questions.